solving equations with variables on both sides. What's most important about solving equations with variables on both sides is to first move a variable so it's only on one side. As I look at the left, I have a 5x minus 1. On the right, I have x plus 15. 5x and a 1x, but they're on opposite sides. The 1x is smaller. I'd recommend moving that. Because it's positive, I'm going to subtract my x here, subtract my x here. Keep in mind you want to focus on doing this directly below like terms. 5x minus x is the same as minus 1x, leaves me with 4x. I bring straight down my minus 1, bring straight down my equal sign. X minus x is 0, it goes away. I can bring down my 15. Now it's like an equation that we've been solving all along. I have to move the 1 and I have to move the 4. If I were to translate this, it would be 4x minus 1 or 4 times x minus 1. Just move the minus 1. I will add 1 to both sides, directly below like terms again. 4x is all that's left on the left. 15 plus 1 is 16. 4x is multiplication, so I will divide on both sides by the 4 to move the 4 and leave only the x. Bring down my equal sign. 16 divided by 4 is 4. My variable is isolated and I'm done. Problem 2 here, I have my equal sign dividing it into two separate sections. What's different about this one is now I have a negative 2y on the left and a positive 3y on the right. If you have a negative and a positive on opposite sides, I would recommend always moving the negative. Doesn't matter if you're moving it to the right or if you're moving it to the left. That's my recommendation. It's not the only way to do it, but I recommend that because that way you're dealing with a positive coefficient in front of your variable. Because if it's a negative 2y, I have to add 2y to both sides. Now, on the left, the 8 comes down, but a negative 2y and a positive 2y cancel. I can bring my equal sign down. A positive 3y and a positive 2y gives me positive 5y. Bring the negative 2 down. It's a two-step equation now. I'm subtracting 2. I need to add 2 to both sides. I can bring my 5y down on the right. I can bring my equal sign down. The negative 2 and the positive 2 cancel. 8 plus 2 is 10. One step remaining to get the y by itself, and that's divide by the 5 since I'm currently multiplying by 5. That leaves just the y on the right. I bring my equal sign down. 10 divided by 5 is 2. Does not matter if you have that or if you have y equals 2. If you had decided to move the 3y from the right to the left, you would have got the same thing. You just would have been dealing with more negative numbers than the way that I did it. Both ways are correct. Both ways mathematically will work. If you show me all your steps, it does not matter which way you use. I'm going to scroll down here and take a look at two different types of problems. If we look at these, the major difference with number 3 is I have these parentheses on both sides. We don't want to do anything until we simplify each side of the equation first. So in this case, if we see these parentheses, we're going to want to distribute. 3 times the q is 3q. 3 times negative 5 is negative 15, so I get minus 15. I want to do the same thing on the right-hand side. I have to distribute that 2. That gives me 2 times q, or 2q. Then I multiply it to a positive 5 this time, so 2 times positive 5 is positive 10. That gives me plus 10. Drop my equal sign. Now I have problems like numbers 1 and 2. I have a 3q on the left, a 2q on the right. They're both positive. The 2 is smaller. I will move that. It's positive, so I subtract it. Directly below like terms on both sides. 3q minus 2q is 1q, or just q. Bring down the negative 15, bring down the equal sign. Positive 2q and negative 2q cancel. Leaves me with positive 10. Only one step left. Since I already have the q with a coefficient of 1, I need to move the 15. Since I'm subtracting it now, I will add it. That leaves just the q on the left. Negative 15 and positive 15 cancel. I bring my equal sign down. 10 plus 15 is 25. Variable is isolated, so I'm done. Number 4 is a tricky problem here because I have to distribute, I have to combine like terms, then I have variables on both sides. Not only that, it's often the case that people distribute the 8 here. But keep in mind, that's 8 minus, not 8 times. So what I'm actually distributing is a negative 1 from in front of my parentheses. So the 8 I don't distribute, I bring that 8 down. And then I do a negative 1 times positive 3 and get a negative 3. I do negative 1 times positive b and I get negative b, or minus b, equals b minus 9. I can't start moving my variable until each side is simplified. Here the left side is not simplified. I have a positive 8 and a negative 3 that are like terms. I can simplify those. Positive 8 and negative 3 simplify to a positive 5. Minus b equals b minus 9. Again, I'm in a situation where I have a negative b and a positive b. Again, my recommendation is move the negative 1 to the other side by adding it. If I have a negative b, I will add a positive b. And I will do that on both sides. A negative b and a positive b cancel. I'm left with 5 on the left. B plus b is 2b, not b squared. And I bring down the minus 9. Two-step equation left. I'm multiplying and subtracting. I need to add first. I get 14 equals 2b. To undo the multiplication, I will divide. 14 divided by 2 is 7 equals b as my final answer.